So, hey guys, I'm Mohit K. Kashyap, studying in SVC College of SVC Bangalore, and I'm pursuing my BTech in Electronics and Communication. So, as you can see that I've got a pretty decent background. So, today I'm gonna teach you guys about external communication interfaces for embedded systems. So, what do you mean by external communication interfaces for embedded systems? So the first question that pops into my head is, what is external communication interface? External interface is interface between input-output interface and peripheral devices. Interface can be of two types, parallel interface and serial interface. So today we are going to learn about four types of external communication devices. No, five types, which are IRDA, USB, Bluetooth, Wi-Fi, and Zigbee. So what is an IRDA? IRDA is an infrared data association. So these are used in mobile phones, digital cameras, keyboard, mouse, printers to communicate laptop computer and for data and pictures download and synchronization. So used for control TV, air conditioning, LCD projector, VCD devices from a distance, just like a remote. You guys have seen remote, right? At the tip of the remote, you guys see an infrared red light. So here we are explaining that thing, okay? And we use infrared after suitable modulation of data bits. Communicates over a line of sight phototransistor receiver for infrared rays. So it does not communicate. It communicates in a certain pattern, which is known as the line of sight phototransistor for infrared rays. So as we have moved on to our next slide, so here I'm gonna teach you guys about the IRDA protocol suite. Then this supports data transfer rates of up to 4 Mbps. Please note here Mbps means megabytes per second, not megabits per second. It supports bidirectional serial communication over viewing angle between plus 15 degree plus or minus 15 degree and distance of nearly 1 to 5 meters. The IR transfer data can be up to data transfer rates of 75 kbps, which is kilobytes per second. So the next point is there should be no obstructions or wall in between the source and the receiver. For example, if you're gonna operate your TV using a remote, so you have to point a remote directly at the TV. If there is an obstruction, just like a wall or something else, the remote, the infrared rays present in the remote, it won't be able to communicate with the TV. So there should be no obstructions or walls in between the source and the receiver. So let's move on to the next slide. So here we are going to discuss our next topic, which is Bluetooth. So I guess Bluetooth is a household name. Everybody in this world knows about Bluetooth. But here we are going to study in depth about Bluetooth. So as we all know, Bluetooth is a wireless technology standard for exchanging data over short distances. It uses short wavelength UHF radio waves in the ISM band from 2.4 to 2.485 gigahertz from fixed and mobile devices and building personal area networks, which is PAN. It was invented by telecom vendor Ericsson in 1994. It was originally conceived as a wireless alternative to RS-232 data cables. So Bluetooth is managed by the Bluetooth Special Interest Group. Uh, they have created a special organization for managing this Bluetooth, which is known as Bluetooth Special Interest Group, which has more than 35,000 members, company in the areas of telecommunication, computing, networking, and consumer electronics. A manufacturer must meet Bluetooth 6 standards to market it as a Bluetooth device. Okay, they have to take permission from the SIG group, which is special interest group for marketing its device as a Bluetooth device. Just like if you want to create a helmet, you have to take the permission from ISI. There has to be an ISI mark. Similarly, to make to use your Bluetooth on your device, you have to have the permission from special interest group, which is known as SIG groups. So Bluetooth operates at the frequencies between 2402 and 2480 megahertz, or 2400 and 2483.5 megahertz, including guard bands, 2 megahertz wide at the bottom end and 3.5 megahertz wide at the top end. Okay, this is in the globally unlicensed but not regulated. Okay, industrial, scientific, and medical 2.4 gigahertz short range radio frequency band. Okay, so Bluetooth is a radio technology called frequency hopping spread spectrum. So how does like it has to use a technology, right? Simply you can't just create Bluetooth. So Bluetooth is a special technology known as special frequency hopping spread spectrum. Bluetooth. So I'm going to teach you how it works. Okay, Bluetooth divides the transmitted data into small packets and transmits each packet on one of 79 undesigned Bluetooth channels. Okay, it divides the transmitted data into packets and transmits each packet on one of 79 designated Bluetooth channels. Each channel has a bandwidth of 1 megahertz. So it usually performs 800 hops per second with adaptive hopping enabled. Adaptive frequency hopping enabled. Bluetooth low energy uses 2 megahertz, which accommodates 40 channels. Okay, I guess you guys have understood what I'm teaching. So let's move on to the next slide. Originally, we had only Gaussian frequency shift keying. Modulation was the only modulation scheme available, like in the earlier days. Since the introduction of Bluetooth 2.0 plus EDR, pi by 4 DPSK, DPSK means differential quadrature phase shift keying, and 8 DPSK modulation may also be used between compatible devices. When you come to the 6M in EC, you learn about various types of FSKs and PSKs. Okay, then devices functioning with GFSK are said to be operating in basic rate mode, which are instantaneous bit rate of 1 mbit per second is possible. Okay, the term enhanced data rate EDR is used to describe pi by 4 DPSK and 8 DPSK schemes, each giving 2 and 3 megabits per second respectively. The combination of these BR and EDR modes in Bluetooth radio technology is classified as BR or EDR radio. So moving on to the next slide. So our next topic is about Wi-Fi. As we all know what Wi-Fi is, in today's world we can't do anything without Wi-Fi. It's in every house. So Wi-Fi is become an essential part of our lives. So let's learn about Wi-Fi then. Wi-Fi is a technology of wireless LAN with devices based on the IEEE 802.11 standards. Wi-Fi is a trademark of the Wi-Fi Alliance, which restricts the use of the term Wi-Fi certified to products that successfully complete interoperability certification testing. So the Wi-Fi name is patented. Devices that can use Wi-Fi technology include personal computers, video game consoles, phones, tablets, digital cameras, smart TVs, digital audio players, and modern printers. Wi-Fi is even used in medical fields such as MRI scan and CT scan things. Wi-Fi compatible devices can connect to the internet via WLAN and a wireless access point, such as an access point, a hotspot, has a range of about 20 meters indoors and greater range outdoors. So Wi-Fi has a very small range. So hotspot coverage can be as small as a single room with block radio waves are as large as many square kilometers by using multiple overlapping accessing points. So moving on to the next slide. So Wi-Fi most commonly uses the 2.4 gigahertz UHF and 5.8 gigahertz of SHF ISM radio bands. So anyone within the range with a wireless modem can attempt to access the network. Because of this, Wi-Fi is more vulnerable to attack than wired networks. So Wi-Fi protected access is a family of technologies created to protect information moving across Wi-Fi networks and include solutions for personal and enterprise networks. So security features of Wi-Fi protected area access constantly evolve to include stronger protections and new security practices as the security landscape change. So they are constantly improving the security parameters of this Wi-Fi connections to prevent the leakage or corruption of your data. So moving on to the next slide. So our last and final topic of this session is ZigBee. ZigBee is an IEEE 802.15.4 base specification for a suite of high-level communication protocols used to create personal area networks with small, low-power digital radios, such as for home automation, medical device data collection, and other low-power, low bandwidth needs designed for a small-scale projects which need wireless connections. Hence, ZigBee is a low power, low data rate, and close proximity, that is personal area wireless ad hoc network. The technology defined by the ZigBee specification is intended to be simpler and less expensive than other wireless personal area networks, such as Bluetooth or more general wireless networks such as Wi-Fi. We are just gonna say that it is more affordable than Wi-Fi and Bluetooth. Applications include wireless light switches, home energy monitors, traffic management systems, and other consumer and industrial equipment. Equipmental requires short range, low rate wireless data transfer. So moving on to the next slide. In this slide, I'm going to teach you guys in depth about ZigBee. So its low power consumption limits transmission distances to 10 to 100 meters line of sight, depending on power output and environmental characteristics. ZigBee devices can transmit data over long distances by passing data through a mesh network of intermediate devices to reach more distant ones. ZigBee is typically used in low data rate applications that require long battery life and secure networking. ZigBee networks are secured by 128-bit symmetric encryption keys. So it is a type of encryption code, you can say. So ZigBee has a defined rate of 250 kilobits per second. So kilobytes and kilobits are two different things. Okay, just don't confuse yourselves. Best suited for intermittent data transmissions from a sensor or input device. ZigBee was introduced in 1998, standardized in 2003. The name refers to the waggle dance of honeybee returned to the beehive. So moving on to the last and final slide of our session today. So here in this slide, we're going to discuss about the typical application areas of ZigBee. So it is used in home environment and control, home entertainment and control, home automation such as in QVCon lab, smart lighting, advanced temperature control, safety and security, movies and music, wireless sensor networks, starting with the individual sensors like TeleOSB or T-Mode and IS from MEMSIC, industrial control, embedded sensing, medical data collection, smoke and intruder warning, building automation, remote wireless microphone configuration. So I hope you guys really like my video. If you didn't like it, no problem. I don't care. So let's finish our session over here today. Thank you guys. Thanks for cooperating. Bye guys. Have a nice day.